Hi there. Okay, we are going to just talk quickly about how to use the mean, standard deviation, and standard error to make error bars for your graphs for this enzyme lab. So what I've done here is I have made a histogram for some times of a yeast sphere to rise. The reason I did that is so that you can see that this data forms what we call a normal distribution. That means that another word for that is like a bell curve, where you have a peak in the middle and it goes down on the sides. The average for this histogram, the average for this data is 8.95, and you can see that in this histogram that value falls into the category that has the highest amount. So the reason that's important is because once it's a normal data, normal curve, then we can calculate standard deviation and means. So the means you've already calculated, and standard deviation represents the distance from the mean that data falls. So if you have a small standard deviation, it means you have a lot of clustered data. If you have a large standard deviation, it means your data is spread out. It has a larger range. So standard deviation itself can tell you something about your data, but we also want to take a look at something called standard error of the mean. Standard error of the mean tells us about the confidence we have in our mean as representing the value that we were trying to measure accurately. So two things to tell you about the standard error of the mean. First of all, when we think about the number of trials, the higher the number of trials you have, the smaller your standard error of the mean would be. This makes sense because the trials represents N represents the number of trials or the number of subjects. S represents the standard deviation. So if you're dividing by a larger number here, this number gets smaller, the standard error gets smaller. So the other thing to say here is that the more variation you have in the population, the more the less certain your mean is. In other words, the larger your standard deviation, the larger your standard error, vice versa. If you have a very small standard deviation, you'd expect to have a small standard error as well. So standard error is helpful to us mostly because it gives us a rough sense of how close our data is to each other or how far away from it is from each other. And this is a little bit confusing, but basically what this means is that if your standard error is too large, then you have less confidence in that mean as representing the actual value, and so then you can't really determine that two values are different. So for example, in A, even though these mean points look to be different, because the standard error represents, let's say this is 10 and the standard error is 0.2, this would be 10.2 and 9.8, it means that our mean falls within that range. And if this mean falls within this range, because they overlap, we can't really have confidence that those numbers are actually different from one another. Compared to C, there's no overlap, so we have much more confidence that those values are different. And again, that just tells you something about the quality of your data and how much confidence you can have in it. So if you were to look at this graph, it says in which set is the middle group most different from the others, so set 1 or set 2. So you can see here that set 1, there is no overlap of this green bar with either the yellow or this other green bar. Compare that to here, there's overlap completely with this yellow bar. So theoretically, actually, not theoretically, but actually these numbers don't actually represent different values. They could represent the same value. And so therefore you wouldn't say that those are actually different. So that's important because in your data, you're going to actually be graphing your means, but then your standard error. So this line will go up 1 standard error and down 1 standard error. So again, if this point, let's say this point represents 3.7 here, that's the mean, then the standard error would be, I don't know, 0.4, something like 0.6. So 0.6 above, 0.6 below, that's how you would draw that line. Okay, good luck. Hope it goes well.